I kind of spoiled the story for this video and the last video, but again, just as a reminder, when we talk about a given function, the derivative of the function is found by the limit of the average rate of change, which is known as the instantaneous rate of change of the function with respect to the input variable. So in most cases, an instantaneous rate of change in y with respect to x. And so that's kind of captured in this first paragraph. So then this video is just going to look at a couple examples, one coming from the study of economics. And so if we're supposed to just find the average rate of change in the first part, right, as x changes from 100 to 105, right, I could say that, AROC is equal to change in cost over change in x. So this is in the denominator at least, 105 minus 100. I could do it in the other order, but then it'd be c of 105 minus c of 100. Okay, and if I do the calculation at the end, I should get 2025. Okay, and so what this is saying in words is that on average, there is an increase of $20.25 for producing one additional unit, because there is a denominator of 1 here, for producing one additional unit. Okay, and so now we have an idea of what the average rate of change is. Let's look at the marginal cost, which it says is the instantaneous rate of change. It's the derivative of c at 100. And so now if I go ahead and proceed with that, so c prime of 100, oops, not 110, this should be limit as h approaches 0. I'm using that version instead of the f of x2 minus f of x1. The denominator being one thing is generally easier for us to work with. So it'd be c of 100 plus h minus c of 100 all over h. And so proceeding with this limit as h approaches 0, substituting this in, I should get 5,000 plus 10x plus 10h, distributing that. If you need to show more work, please do. Sorry, try that again. I should probably show more work, right? 100 times 10, so that'd be 1,000 plus 10h, and then plus 0.05, and then times 100 plus h squared, and then this ends up being minus 6,500 if you do the calculation all over h. Okay. And I'm going to say dot, 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 a little bit of algebra later, right? Like you can see the 5,000 and 1,000 are going to reduce to 6,500, and then you have to, expand all this out too. But what we end up getting, if we do the simplification, is limit as h approaches 0 of 20 plus 0.05h. And that's after dividing by h and all that stuff too. And then so the limit as h approaches 0, this is just going to be 20. Okay, and so then what this is saying is that there is a cost of $20 per unit when producing 100 units. Okay. So there we go. Now that one was more of an applied setting where there was a nice function. In other cases, you're given something like this, where it's like, whoa, what do we do? Okay, so we have temperature, big T, given at a particular time, little t, in Baltimore T hours after midnight on a particular day, and then we want to find and interpret T prime of 10. Oh, and that's the other thing. When we talk about the derivative here, this apostrophe, we talk about that as a prime, okay? So if we were to do this, okay, how could we find T prime exactly? Because our derivatives, right, they're defined as a limit. I don't know how to do a limit when I'm given a table, right? Our derivatives are given with functions, okay? So what we could do is, I'm just going to outline this as a general idea. Okay, you could look at, if we're trying to estimate T prime at 10, right? What we could do is do the AROC, average rate of change, between, say, the points 865 and 1076, and then also, so that'd be one average rate of change, and then another average rate of change between 1076 and 1285, right? And then what we can do is, it's kind of weird, but we could average the averages. Okay, and then just note that this is going to be an approximation. Okay, and so here when it says find, I personally don't know of how you can find it precisely when you don't know the exact function, but this would be the best that we could do. And so if you go through and do the average rate of change of this first set and then also the second set and average them, add them up, divide by 2, right? What we end up with is that T prime of 10 is approximately 5 degrees Fahrenheit per hour. So we're saying that the temperature is increasing at 5 degrees per hour at 10 hours after midnight. Okay, so that's how we could interpret that in words. So we now have a few contextual examples of how the derivative works. One where it's a little bit kind of ill-defined, at least the function in terms of its algebraic form. And then one where we have a nice algebraic form and then went through and found the limit.